Hello, everybody. Welcome to a new webinar on automatic detailing of rebars in reinforced concrete structures. My name is Evaristo Morata, and I work as a Middle East countries developing markets. It's my pleasure to introduce you to David de Dios, who is architect in our company, CYPE Software. And today we will talk about the design, analysis, and sizing about the structure in CYPECAD. And then we will carry out the BIM modeling of the rebars in reinforced concrete structural elements with the program called StruBIM Rebar. So at the end, we will be able to get a list of quantities and detailing drawings, which is something very, very extraordinary regarding to this kind of programs. So it's up to you to start, David, whenever you want.
Thank you very much, Evaristo, for the lovely introduction. And now, if you allow me, I will start sharing my screen so we can continue with the live demonstration.
Okay.
So this is BIMserver.center, which is our common data environment. And if you create an account today, you will be able to access all of the tools that we're going to show you today. If we go to the store, you will see that we have tools for many different kinds of trades in the construction sector. And of course, today we're going to center our efforts on the structural analysis category here with CYPECAD, which is our tool to model, analyze, and generate all the reports and drawings that may be necessary for all kinds of structures, including, of course, reinforced concrete structures, as well as StruBIM Rebar, which is a tool that we will use later using the analysis of CYPECAD in case we need to generate custom detailing for all kinds of rebar solutions. If you'd like to know more about the tools that we're going to show you today, you can always access the application website of each one of these tools. And from there, you will be able to download the tools as well as access all the detailed information, as well as learning resources like the webinar that we are holding today. So, going back to BIMserver.center, the other side of BIMserver.center is the project management side of things. That is because you can upload all of your data to a project where several people can work in parallel at the same time. And we're going to do this as well. So that way we can send the data from the analysis to our detailing solution and vice versa. So without further ado, let's go to CYPECAD so that you can see what I'm talking about. CYPECAD is a tool that we can use to design reinforced concrete buildings like the ones that you're seeing in here. And the main advantage of working with CYPECAD is that we work with a floor-by-floor approach. So that allows us to automatically size all the elements and apply all the loads that may be applied to our building, either vertically as well as horizontally, like seismic loading and wind loading. So no matter the geometry of your building, we'll be able to apply automatic seismic loading as well as wind loading, among others. I'm going to create a new project, and I'm going to show you how you can work either the old-fashioned style based off of the XF and hydrology drawings, or how you can reuse the data from any architectural modeler out there, like Revit, ArchiCAD, Allplan, or even our very own CYPE architecture, which is something that we provide for free for everyone forever. So, first things first, we will start with the old-fashioned method, if I may. So let's create a new job here in CYPECAD. And you can see that when I create a project, I can link it to a BIMserver.center project if I want to. In this case, we're going to start the old-fashioned way, so we're going to leave it offline. And the first thing that we get when we start with CYPECAD is the general data menu, where we can set up the building codes that we're going to use for our building. You can see that by default, we support several building codes from around the world, like Eurocode, British Standard, American Standard, as well as many other ones from countries like Russia, as well as Chile, Peru, and so on. But in this case, if I may, I'm going to use the Eurocode for all materials that we're seeing in here. Inside CAD,
David, I think this is very important for all our audience to know that we have a lot of possibilities regarding the codes. Because you are displaying all the codes, and then many countries are let's say involved in this list of codes. And I tell you this because sometimes customers ask me about this, about the codes, and even from many countries they can adapt to some of them, like European, like UK codes, and even to American codes. That's true.
Yeah, in that sense, we are quite flexible, as you can see. It's just a matter of selecting the building code you want to work with, and you can even switch them later if you'd like to reanalyze the structure using a different building code as well. Once we select the building code that we're going to work with, you can see that all the materials have been updated, and we can continue with things like, for example, the automatic loading that I was talking about before. In this case, as you can see, we can have wind load codes so that we can automatically add all of these wind loads to our building, no matter its geometry. And it's just a matter of selecting the building code that we want to work with and setting up some basic parameters for the analysis. Things like, for example, the tributary widths, as well as the reference speeds for wind, and things like the terrain categories and land orography in our case. Same thing applies, of course, with seismic loading. And you can see that the idea is exactly the same. You can select the building code that you would like to work with. Or if we don't have the building code that you're used to work with, you can always work with the general method as well, so that you can have your own custom spectrum for the dynamic seismic loading. And we can even go as far as to check the fire resistance for all the elements in our building. So we're done setting up our projects. We will start modeling our structure. And as you can see, we work with a 2D space-based model, where we start first with a column definition here on the bottom left. And once we have our columns ready, we will switch to the BIM definition tab, where we will start by setting all the different floors of our structure. So let's start adding, for example, here, 2 new floors. We'll have one above ground level, like so. And we can set up the live loads and dead loads that will be applied by default uniformly throughout the floors. So we could have something like this, for example, in kilonewtons by square meter, of course. And once we have our levels ready, we will be able to start adding the vertical elements, that is, the columns. I'm going to work with reinforced concrete columns, of course, but if you need to work with steel members or with composite sections, timber, or even your own custom generic elements, you can do so as well. By default, we can work with rectangular or circular columns, and if necessary, you can even create your very own sections. So that way, CYPECAD will generate all the geometrical and mechanical data for the analysis. So if you need an L-shaped column like this one, you can customize it, and then the software will...
This time you have created your own shape for the element. This is what I see. No, it's not let's say it's not a generic shape, but it's a shape that you have invented. Let's say that.
Exactly. And as I mentioned, the mechanical characteristics can be automatically analyzed by the software. But if I wanted to, I could pop under the engine and add my own values. But in this case, as I said, I'm going to work with rectangular shaped columns.
Okay.
And before we start, you can see that I'm working with an empty canvas, of course. So if I want to, I can work with an empty canvas, or I can import a DXF or DWG drawing as a basis for my project. In this case, you will see that I have already imported some drawings from the architect, and I can use this as a basis to start modeling my structure. So let's snap my cursor to this drawing right here, and we can start adding our columns. As you can see, when I start adding my columns, a series of grid lines will appear as well, so that the column introduction is smoother on my end. I'll try to be very brief with this, of course. And once I have,
because you know exactly where to install the columns, no? You know exactly, or even because of the program CYPECAD tells you where to install the columns. That's right.
Well, as you can see, I can either snap to my drawing, or if I want to, I can just turn off the model, and then I can work freehand. So that way I can insert my own grids like so. So I could have something like this. I'm almost done with this. So once we have our columns, we will be able to continue with the horizontal elements in the BIM definition tab. In this case, you can see that I'm inserting centered columns in regards to the grid lines that we have generated. But if I wanted to, I could slant those elements so they are not centered on the middle part of this column, but instead they could, for example, be switched around so that they are centered on one of its sides or one of its corners, like so. So it's quite flexible in that sense.
So total we have 16 columns.
Exactly. So now that we have our columns ready, we can continue with the BIM definition tab. And as you can see, we work with a 4x4 approach for our modeling. And in this case, we will start by the foundations. I'm going to turn off the template so you can see what we have up until now. And in this case, what I'm going to do is that I'm going to work with pad footings, because I can generate pad footings with strap and tie beams automatically. But if I wanted to, I could work with other kinds of foundations. For example, I could work with matte foundations like these ones, where I can set the persistent situations for the analysis either manually or based on the typical project values that we have on our database in here. Or I could even work with other kinds of point elements, like, for example, I could work with piles and pile caps, like these ones. So by setting up the kind of pile cap that I'm going to use and the kind of pile cap, I can then model pile caps like these ones to my liking. But as I mentioned, in this case, I would like to work with the automatic design for strap and tie beams as well as pad footings. So I'm going to use that instead. And if we go back to the 3D view here, we will see that our building is starting to slowly but surely to take shape.
Yes, nice. You have changed from 2D to 3D. But let's say the beginning of the design, you have made it on 2D. This is what I understand.
Exactly. So there's no need to take care of generating a 3D model because the software is doing that for you. So let's continue with the modeling, and let's go, for example, one level higher so that we can start with the above ground level. I could start, for example, by adding beams, of course, and you can see that by default, we can work with many different kinds of beams. We have different families like flat beams, as well as drop beams, lattice beams, pre-stressed beams, and as I mentioned before, we can also work with steel and timber elements if necessary. When I select a family, you will see that I can choose from many types inside that family so that I can later customize the geometry and the disposition of our elements. In this case, I will work with a regular drop rectangular beam, and as you can see, I can even set it up below the slab if necessary. So once I have my beams, I can start modeling like so. I can either snap to the elements that I have, like my columns, or I can snap to my drawing, as you can see here. It's up to you. Actually, in this case, I'm going to work a little bit freehand, like so. And I will start by setting here the bounding elements for our slabs. You can see that once I have 3 or more bounding elements, I have in here my slabs pending to be defined. But let's not get ahead of ourselves. Let's finish here with the modeling.
Yeah, always CYPECAD show you the question mark, like inviting you to finish with the beams. I mean, the design of the beams. This is what I understand from this design. Okay.
Correct. And you can see that if I needed to have overhangs like these ones, I can use my template as a basis to snap to it. So in this case, I'm going to add a few more beams, and once I'm done, I will continue with the panel manager so that we can start with our slabs, of course. We have special kinds of beams, and you will see why I'm mentioning that in a moment. Because in this case, if I wanted to have, for example, a bounding beam for this overhang, it's something that I could model as well. And in this case, just like before with the columns, I can also slant my beams to one side or the other, depending on how I would like to model my beam. So I could do something like this, for example. And you can see that if I go back to the 3D view once more, slowly but surely, we start to have something closer to what would be the actual structure. If we go to the panel manager, we will be able to delete panels so that we have openings, like here for the patio, and we will be able to define many different kinds of panels that come pre-built into the software. So if I wanted to work with choice floor slabs, hollow core slabs, composite slabs, waffle or coffer slabs, as well as flat slabs, I could easily do so out of the box with CYPECAD. In this case, I would like to work with flat slabs, and it's just a matter of setting the properties for this slab, in this case, the depth, and I can select the panel that I would like to describe as well as its direction. So I can start defining my floor like so. If you're working with a building that has several repeating floors, you can group them, or if you want to, you can just copy one floor to another, which is what I'm going to do. I'm going to jump to the roof here, and I'm going to go to groups, copy from another group, and I'm going to copy the modeling that I've done previously. So our building is almost ready, as you can see.
So that this part you have copied from below, and you have pasted, let's say, and it's exactly the same. So
Exactly.
it's a nice way to save time.
For sure. That's if you are working the old-fashioned way, because later I will show you how you can reuse an architectural model like the one that we've seen before. So if you think that this saves time, you won't believe what you'll see later.
Okay.
You've seen that up until now we've worked with beams, columns, and slabs, but if I wanted to work with, for example, walls, I could also work with structural walls made out of reinforced concrete, as well as concrete blocks and masonry walls, so that we can later analyze its behavior under stress, and so that we can automatically size all the rebar that may be necessary for those elements. We can also take into account building elements for the stiffness as well as the weight that will be added by, for example, a facade, which is what I'm going to do right now. I'm going to add here a facade to my building, which will be taken care of later, both for the dead loads as well as for the seismic analysis for the rigidity of the model. So I'm going to add a new masonry type. And I can either fulfill all of these values manually, or I can use a library of predefined elements that we have inside CYPECAD, which is what I'm going to do, of course. In this case, we're going to have a double leaf external wall with, for example, a 12 plus 12 centimeter hollow ceramic brick. And you can see that when I select this element, all the properties for the seismic analysis as well as for the surface loads have been updated as well. And now that I have my material ready, I can start drawing my facade like so. Just like we did before, we can snap to the elements that we've modeled previously, or we can use the template that we have in the background as a basis. In this case, I think that I can get rid of the template because basically we have the outline of our building. So let's declutter the drawing and let's continue with the walls. I'll try to be very brief with this one, so bear with me. Okay, we're almost there. And as I mentioned, this is something that we can also import from the architectural model if we've done so previously, if we have an architectural model, of course. Couple extra walls in here. And there we have it. We can also have other kinds of structural elements as well, which I'm going to show you in a bit. We can also add point loads, line loads, and surface loads if necessary. Like let's say, for example, that we wanted to add a dead load or a live load or any other kind of load that is linked to the load cases that come by default with the building code that we have selected. And we can add them to our liking, like so.
So what does it mean? Live load is a part of the room or part of the surface that will hold a special weight or a special movement of live load. That means maybe people or whatever. That's right.
Exactly. By default, we work with load cases that come with the building code, but as you've noticed in here, we can have additional load cases, special loads for things like, for example, snow, temperature, soil pressures, and you can even have several kinds of dead loads and live loads, so you can take into account the weight of furniture, people, and so on.
Okay, I understand. Yeah.
In this case, you can see that I've added a surface load, a point load, and a live load that can line load, that can be applied freely wherever you want. And as I mentioned, we also had other kinds of structural elements that we can model besides beams, columns, slabs, walls, foundation elements, and so on. And the last element that I would like to show you here is the staircases. We have a series of macros of staircases that you can add to your model, and we will take into account both the loads that are generated by the staircase as well as the internal loads for the staircase, so that we can design the rebar for that as well. Same thing applies also for ramps, which is a new feature that we have implemented in version 2024 of CYPECAD, and it works exactly the same as with the stairs I'm going to show you right now. So let me first delete here a panel, and let me go one level lower in here so that we can insert a staircase. I'm going to select, for example, this macro right here. And if I wanted to, I could customize it to my liking, as you can see. So we can have free shapes for staircases and so on. And all I have to do is just put it on a 2D view, like so. And then if I go to the 3D view, you can see that we have our staircase element waiting to be analyzed. So this would be basically the end for our modeling. But as I mentioned before, CYPECAD is not only a modeling tool, but is a full solution for reinforced concrete as well as steel, timber, and aluminum structures, so that you can design them, analyze them, and get all the checks, reports, and drawings automatically. So that's what I'm going to do right now. And if I go here to the Analyze menu, I can analyze the whole structure, which is going to take a couple seconds. Meanwhile, I would like to go back to our architectural model because, as I mentioned, this is the old-fashioned way of working if the architect only gives you DXF, DWG, or PDF drawings. So if you work with an architect that has an architectural model that can come from Revit, ArchiCAD, Allplan, or even our very own SYPE architecture, you can take some of the properties that we have in here. Like, for example, you can see that this architect has modeled some beams, columns, slabs, and so on. And we can take all of this data back into CYPECAD so that we can have basically most of the analytical model that we've generated before by hand. There's no need to get into the specifics of how our structure is going to behave in the architectural model. And you can see that in this case, it's a relatively bare bones structure, and that's done on purpose because all of the data for the analysis, the loads, as well as the rebar and so on, that's going to be taken care of by CYPECAD and the engineer, of course. So let's go back here to CYPECAD, and you can see that we finished with the analysis. So that if we switch to the results tab, and we take a look at the full 3D view, you will see that the software has sized all the elements and it has designed all of the rebar for us. What you're going to see is something that the software has done from scratch. So you can see that we have all the rebar for all of our elements: beams, columns, slabs, pad footings, strap and tie beams, staircases, and so on. Mind you that this is something that CYPECAD has done for us.
We can see everything here. I mean, even the inside, the reinforced inside, right? The steel reinforced. What I mean.
Exactly. As you can see, we have both the traverse as well as the longitudinal reinforcement for all the elements that we've mentioned. So now that I'm done, here comes the fun part, of course, which is generating the reports and drawings. Nobody said that before, of course, but with CYPECAD, it's something that is way easier to do than before. For example, if we wanted to take a look at the internal analysis for any element, like this beam right here, you can see that we can take a look at the rebar that has been designed by CYPECAD, of course. And we can take a look at the checks that have been performed for each element, like so. We generate a step-by-step analysis, like the one that you can see in here. And when we're done, we can export this, if we want, into a full report that can be later saved as a PDF, HTML, Word, and so on. So if you don't believe us, you can always take pen and paper and you can compare the analysis that we've done internally with your own checks. You can see that we cite the building code that we are using, as well as the articles and steps required to get to the final result.
So you have there a complete report of the design. This is what I see there. Okay, this is nice because CYPECAD deliver automatically and no need to make to use another different program, but directly from CYPECAD. This is what I see, right?
Exactly. It's a basically one-stop shop for all kinds of structures. And as you can see, CYPECAD has suggested this rebar for this structure. But if you're not happy with this, no problem. We can customize it to our own. And actually, I would like to do something a little bit silly, so you can see what I'm talking about when we talk about the step-by-step analysis. You can see that now I put in something a little bit silly in regards to the number and diameter of the longitudinal rebar in here. And if we take a look at the checks, we can see that some of them have not been performed accordingly, and we can see why our structure is failing. Of course, this happens because I've manually edited these values, but if I wanted to go back to an ideal solution, I could just rebuild the frame like so. And you can see that CYPECAD has once more suggested something that is a little bit more sensible to our structure.
I understand.
And this applies, of course, for all the elements I'm talking about, not only beams, but also columns, slabs, pad footings, walls, and so on. We can also generate drawings with all of this data, and just like we did before with the analysis, all of these drawings will be generated automatically by the software as well. I can have many different kinds of drawings by default, and I'm talking about things like the detailing of columns, or frames drawings, or for example, layout plans, column schedules, and so on. And for each one of them, I can customize the properties for things like, for example, the pen thickness and the text annotation scale, as well as the scales for the drawings that I'm going to have into these layouts, as well as what elements are going to be drawn for each detailing, as you will see here. We can even add title blocks if we want, and we can import our very own if we have a DXF or DWG drawing with all of this data. So let's click accept, and let's see what CYPECAD has prepared for us. Of course, I have to give some very basic details for the title block as well. And let's give it a couple seconds. This is something that normally should take less than a minute, as you can see. And when we're done, we will be able to export all of these drawings that you're seeing here into a PDF,
very nice.
DXF, DWG.
So all the drawings are there with all the details directly from CYPECAD. This is the point. It's great. You can get the reports, you can get the drawings working with CYPECAD without using any other additional program. This is nice and very quick. Save a lot of time.
For sure. This way you can focus on taking decisions on how the structure is going to be designed instead of wasting time basically working as a draftsman. If you want, you can edit the composition of all of these drawings inside CYPECAD as well. And you can see that it contains all the relevant data for each element. In this case, for example, we have some calendar schedules, but we can also have some frames drawings like the ones that I've showed you before, or column drawings like these ones, where we can have some very basic views of quantities, as well as pending schedules, sections, and of course, all the dimensions for all the elements that we have for the rebar that has been designed by CYPECAD. And as I said before, when we are done, we can export all of these into several different kinds of file formats like PDF, DXF, DWG, and so on. So if you want to, you can just finishing here working with CYPECAD, or if you'd like to, you can always send all of this data to a BIMserver.center project, and there you will be able to reuse all of this data for further design and analysis. In this case, for example, what I've done is that I've exported this project before into BIMserver.center, and I've sent it to StruBIM Rebar so that I'm able to generate custom drawings for my rebar. As you can see, it's just a matter of bringing all of the information that we've modeled before in CYPECAD into StruBIM Rebar with the help of the BIMserver.center menu here on the top right. And we will be able to customize all the elements that we've modeled previously with CYPECAD or any other structural analysis engine for the matter. So we can customize the grade of the steels that we're going to use, as well as the diameters that come either by default into the software or the ones that we would like to customize and create on our own, as well as...
Excuse me, you are modeling now the rebars in the reinforced concrete structural elements. I think that's the use of this program, StruBIM Rebar.
Well, in this case, what I'm doing is that I've already designed all of these in CYPECAD, and I've reused all of this data from CYPECAD so that I can generate custom views. Like, for example, if you have a crossbeam like this one, building, you could have a custom drawing for a crossbeam. So that way, if the drawings that CYPECAD generates by default are not enough, you can always generate your own custom 2D and 3D views like these ones.
I understand, yeah.
So you can see that we can customize the steel grades as well as the reinforcement diameters I'm going to use, as well as, of course, the bar bending codes. You can have your own libraries for all of these elements, and you can export them and import them so that you can reuse them later. In this case, you could see that the software has imported all of the rebar that we've mentioned before, and we can generate a custom view for any of the elements that we have in here. And if necessary, we can also edit the properties of the rebar that we have in here, in case we would like to work in a detached program. So that way you could have, for example, one engineer running the analysis in CYPECAD, and then you can have another engineer setting up the properties for the custom steel detailing with StruBIM Rebar. In this case, you can see that you can change the grades and diameters for all the elements in this specific frame. And they are highlighted here in the 3D view, as you can see. You can change the shape codes as we were mentioning in here that we have in the sketch. And you can generate faces and views for all of these elements, so that you can have your own custom views like the ones that I've shown you here before for this crossbeam. Let's take a look, for example, at this detail, and you can see that this rebar has been imported from BIMserver.center. And what I can do is that I can then populate this view, this drawing, with all the elements that may be necessary, like, for example, like mentions, like these ones, that will read all of the data off of the BIM model as well, or text boxes, so that I can add some annotations to my drawing as well. And when I'm done, of course, I will be able to export all of this data, not only in the formats that we were talking about before, like, for example, you can have reports with a brief description of our structure, or we can have drawings like the ones we mentioned before in CYPECAD, so that we can export it later, for example, into a DWG or DXF or PDF. Or we can go one step further and we can even export an IFC file or a BVVS file with all of this data if it's necessary for your project. So basically, StruBIM Rebar picks up where CYPECAD ends, and perhaps CYPECAD is enough for 90% of what you would normally do in your reinforced concrete structure. So if you want to go beyond, StruBIM Rebar is a companion tool for all of these detailing tools.
It's like yes, if you as you tell me, you have a style to go beyond from the work you have done with CYPECAD, so to make it more, let's say, more perfect, or let's say to improve the structural part, I think.
It's basically customized drawings at the palm of your hand, as you can see, all kinds of reinforced concrete structures. And if you wanted to, this could be the end of your workflow, or if you do, as I mentioned before, you could take an architectural model like this one, and you could import it into CYPECAD as well, which is what I'm going to do right now. So let me close this briefly, and let me show you what would happen if we were to import an architectural model from any other kind of software. So we're going to reuse the data from the architectural model. So let's start a new CYPECAD job. And in this case, we are going to select an existing project. We are going to link to a BIMserver.center project. And we're going to select a project that I have created previously, where I have uploaded this architectural model. If you're working with software made by CYPE, you will see that we always have on the top right corner of your screen the BIMserver.center menu, where you can share all of your contributions, or where you can update, that is, bring all the contributions from your colleagues back into the software. Doesn't matter if you do that with Revit, ArchiCAD, or Oplan, because we also have the IFC uploader for third-party IFC files, and we even have a Revit plugin which allows you to upload all of this data directly to BIMserver.center, which is something that we provide for free, by the way.
Yeah, this is very important. The interoperativity that CYPE provides with different programs, as you told us, the IFC uploader, and the other one was the plugin Revit. Revit plugin. Okay, so this is very, very interesting, and I think it's a feature that users like very much.
So let's reuse the architectural model then by selecting an existing project which already has all of this data, of course. And you can see that now we are importing all of this data so that we can turn the architectural model into a structural analysis model. We will start by setting out first the floor plans that we're going to use for our views. And you can see that it has detected the original floors from our architectural model. And in case I wouldn't like to import one, I could just cross it off the list and it wouldn't be imported. But in this case, I'm going to import all of them, of course. Same thing with the columns. And you can see that the columns have been detected automatically as a reinforced concrete 30 centimeter by 30 centimeter section. But if I wanted to, I could just switch it to another material. So if I wanted to work with steel sections, I could just easily do that as well. But of course, in this case, a reinforced concrete rectangular section like so is more than enough. And same thing applies for the walls. If we have structural walls, that is reinforced concrete walls, place trench walls, or masonry walls, we can import them as well. You can see in this case that the software has detected all of these types of facade as well as partitions and so on. But these are not going to be structural elements, so we can skip this step. And now we can go for the beams. And as you can see, it has detected that we are working with rectangular 30 by 30 centimeters concrete beams. And in this case, drop beams exactly. But if I wanted to switch it to another material like steel or timber, I could do so as well, just like we did before with the columns. Next step would be importing the floor slab outlines. And this is very important because for an architect and for a structural engineer, a slab is not the exact same element because they will have different bounding elements, so to speak, different phases where they will start and finish. So we can import these slabs or we can leave it empty. It's up to us. In this case, I'm going to import the floor slab outlines as well. And last but not least, as we mentioned before, we have a series of walls that are not structural walls per se, but they're going to influence our structural analysis. And I'm talking about, of course, the facades that we're going to have in here. So let's get rid, for example, of the partition, and let's leave the facades and the parapet, which will be used for the wind loading as well. So we are almost done importing our model. You can see that we have no errors whatsoever. So now we can set up our project just like we did before when we started from scratch in CYPECAD. We can set up the building codes, the materials, dead loads and live loads. I'll try to be quite straightforward with this. The wind loading and seismic loading, just like we did before. Accept. And of course, just like we did before with construction materials, we are going to import walls that will be linked to these elements that can add rigidity to the model in case of seismic analysis, as well as to import the line loads that will be applied as dead loads according to the kind of facade that we're working with. So let's check this parapet and facade, like so. You can see that it's the exact same interface that we used before. It's going to be, of course, a hollow ceramic brick, 12 plus 12 centimeters. Like so. And once I'm done, you can see that in the column definition, I already have all the columns that I've modeled previously in the architectural model. And there's no need to model them from scratch, like what we did at the beginning. If we switch to the BIM definition tab, same thing. You can see that we already have all the line loads for our structural elements, and we already have our beams, walls, and so on. Let's take a look, for example, at the 3D view. And you can see that we have most of the geometrical model ready. So if we want to generate the foundations and the slabs like we did before, it's going to be way faster than before. Let's generate here the foundations. And let's add the slabs, flat slabs, of course, just like we did before. And you can see that in a very short span, in less than an hour, we've been able to design a whole structure from scratch, either based on a 2D drawing or on an architectural model like this one. And we've been able to perform automatically the analysis for all the elements so that CYPECAD can design the rebar for us, check it against the building code, and generate all the reports and drawings that we mentioned before. So you can see that only in a couple of minutes I finished with the model, and now I can analyze this structure once more. And in less than a minute, we will have everything that we've generated previously. At the start of this presentation, I've shown you how to work off of DXF and DWG drawings, but if you work in an open BIM environment, like what we do here at CYPE, you can speed up the development of your project, as you can see. And of course, you can have greater accuracy because you're working with a federated model that has the same references for grid lines and so on in regards to the architectural one. So now we can go to the results tab, and you can see that we have once more our glorious 3D view with the final detailing for the rebar. It's going to take a short while, of course, because we are loading hundreds and hundreds of bars. And you can see that we have the exact same result that we managed to have before when we worked off of DXF and DWG drawings. So the process is exactly the same from now on. We can review the results if we wanted to take a look at the checks and the detailing, and we can generate all of these drawings that we've created previously. And with that, we would finish our project with CYPECAD and StruBIM Steel. I hope that this has been an insightful presentation for you all. And if you have any more questions, please don't hesitate to keep in touch with us so that we can better assess your needs.
That's perfect. This is the final drawings.
And it's just like what we did before.
With all the details. Yeah. Okay, David. So I see that you have used especially two programs, CYPECAD, and after making all the design and the analysis, you have used StruBIM Rebar in order to perfection the modeling of the rebars in reinforced concrete structural elements. So for me, it's nice to the way you get the reports, the drawings, everything is very accessible, very easy, and it's not it's not a problem. You don't have to go to another different program. It's very simple. So I thank you for your collaboration. I hope that our audience know a little bit more about these structural programs from CYPE. And okay, in case you have any doubt, do not hesitate to put in contact with us by email or by chat. No problem at all. Okay.
Thank you very much, Evaristo, and thank you all for coming in today.
Okay. Bye-bye.
Bye.